Hello everyone, this is Kalpana. Today we'll see what is fixed size partition and what are all the disadvantage of it. To overcome that issue, what technique we are going to use, all those things we'll discuss today. Fixed size partition scheme. So we have discussed in previous lecture what is fixed size partition scheme and what are the disadvantage we faced here. So we'll see the list of disadvantages that we face in fixed partition scheme. So here maximum process size should be less than or equal to maximum uh, partition size. For example, your partition size is of 50 MB. Definitely that should be your process size should be less than 50. Then only you can execute the process into the you can load that process into the memory. Okay, next the degree of program is directly proportional to the number of partition. So based on how many blocks of memory you have, only we can fix the degree of multiprogramming, or else here the multiprogramming will be a question mark. And next is internal fragmentation, which is we have discussed in the previous lecture itself. For each and every block we say some empty spaces, free spaces available, and further we cannot process that free space for upcoming process. So that is a very big disadvantage of this fixed partition. So that we call it as what? Internal fragmentation. So that is an important thing. If a process of 19 KB wants to allocate and we have free space which is not continuous, we are not able to allocate the space. Since it is contiguous memory allocation, continuous memory blocks only we are going to allocate it. So then and there you have free memories, you can't afford it for the next coming process. So next is to overcome fixed size partition scheme, we have discussed the disadvantages. To overcome those disadvantages, next scheme is your variable partition scheme. Okay, so the name insists we are not going to have any kind of fixed or static blocks. So based on the based on the process, the memory will be allocated. For example, a process is of 20 MB is coming inside. It is going to access the main memory. So at that time, without any partition, at that time your operating system is going to allocate the 20 MB process into the main memory. So here we are not partitioning. Here we are not going to segregate any type of blocks in the main memory. Okay, so whenever the request by the process arrives, accordingly the partition will be made in the memory. So in variable partition scheme, initially the memory will be full contiguous free blocks. Okay, so here we are not going to have any blocks. So memory divided into partition according to the process size. So where process size will vary. So one partition is allocated to each active partition. So it is same like it is also following a contiguous memory allocation, but then like previous scheme, we are not going to fix any kind of block. So let's say variable partition scheme. So this is like your memory is not at all divided into partitions. It is as such. So for example, P1 is requesting, it is of size 50 KB, it is allocated. So after P2 is requesting and it is of 100 KB, it is been allocated. Okay, so like this we can do to avoid internal internal fragmentation. You can avoid internal fragmentation, whereas what happens, external fragmentation may occur. Okay, we'll see what is that external fragmentation. So usually we'll be allocating continuously. For example, after P1, P2 is completing his task and leaving the memory. We are just releasing the memory of P2. A hole will be created. Here if I mean hole, which means a large block of memory is available. Okay, that we call it as hole. So a hole will be created. And so here the system may need to check whether there are processes waiting for memory and whether this newly freed and recombined memory should satisfy the demands of any waiting process. Okay, and then first fit, best fit and worst fit strategies are the ones most commonly used to select the free hole from the set of available holes. So first fit, which means allocating the first hole that is being enough to hold the process, and it is being the smallest hole that is big enough. The worst fit is allocate the largest hole. Okay, so this is your variable partition scheme. So here, as I told you, external fragmentation may happen. So what is this external fragmentation? So occurs when free memory is scattered in small blocks throughout the system. We call it as external fragmentation. So to overcome that external fragmentation, we have solution like compaction, and we need to follow 50% rule. So this compaction is nothing but, so then and there I told you, you are going to have holes, right? If P2 is completing, it is going to release the memory. At that time, a large free space will be created, hole is created. And for example, P4 is being released, and so for P4, at the place of P4, a hole will be created. So like this, then and there hole will be created, right? So using this technique compaction, you are going to combine the free spaces into a new large space, okay, in order to accommodate the new upcoming process. So that is your compaction. And next is 50% rule. Actually, this 50% rule, it says that this compaction will be an effective technique when 50% of your main memory will be free. Okay, if your main memory is 50% free only, then only this compaction will work effectively. So that is your 50% rule. So that's all about today's topic. We'll discuss the next topic in later session.